and 8th graders, and welcome to Lesson 9-4 on reading graphs critically. This is one of the most important lessons in this chapter because it is something that you will use for the rest of your life. The ability to look at a graph and figure out whether or not it's misleading is what we're going to be talking about, because graphs can make data very misleading, and that's what marketing is all about. It's about finding a way to make a graph prove what you want it to prove, and oftentimes it's not really a completely accurate picture of the data. So we're going to look at some examples of that. Here's some common ways that graphs can be misleading. The first way is that they can choose the wrong type of graph to represent the data. Time, like line graphs, are used to show time, and if you try to take something that happened over time and put it into a bar graph, it can sometimes make it misleading. There might be unequal intervals. We learned about intervals earlier on in this chapter, right? If my first interval is only covering 2 numbers and then my next interval is covering, 4, then it's going to make it look like that second one might have more, but really it's just covering more intervals. You also could use too small of intervals, so it won't show enough of a jump, or too large of intervals. If your intervals are marked really close together, it can be hard to read what they are, which can also be misleading. There can be unmarked or unneeded breaks in the bottom of the graph, and we're going to show you what this means. This symbol right here means break. Okay? And we use that when our data has a huge gap between 0 and where it starts. So if our first number was 1,000, then I'm not going to and I'm counting by hundreds, I'm not going to go, 0, 100, 200, 300, all the way up to 1,000 and not have anything written in that. So I can use a little break and then start at 1,000 and then count by hundreds. But sometimes you'll see that it's not marked, that they skipped those numbers, which can be very misleading. So you need one of these break signs. Or sometimes the break isn't needed, and so then it just distorts the data. Another way that it can be misleading is to be missing its labels, because sometimes you might think that something is a much bigger unit than it is. If it was measured in minutes and it's not labeled, you might think that it's hours, so that could be very deceptive. Here are some examples. So here, both of these graphs show the same data. This one and this one. It's showing the exact same information. But you can see that when you look at it, it looks very different. So let's examine them, okay? It says busiest U.S. airports. So this graph is about the busiest U.S. airports. And over here, it says passengers per years, and this is in the millions. So this would be 20 million passengers, 40 million, 60 million, okay? Now, and on the bottom, we have the different airports, Los Angeles, Chicago, and Atlanta. We have this graph, and then we have this one, which the thing that is different is our intervals that we're going up by, okay? This one, the intervals are going up by 20. And in this one, they're only going up by 5. So how is that possible? Well, they cut out all of the numbers from 0 to 55. They just didn't put them in the graph. They also didn't put a break symbol. So if you first look at it, you might just think that Los Angeles only had this tiny little amount of passengers, but really they still had 60 million passengers, which is a lot. And 75 million passengers is a lot too, but it's not that much bigger than 60. It's more like that much bigger. So let's look at why we might choose one graph over another. So which graph gives the impression that Chicago is 4 times as busy as LA? Which one gives that impression? 2? So graph 2 does that. And it's not, is it really 4 times? No, it's not really 4 times busier, but it does look like it's 4 times busier since this is 4 times as much as this. So write that in there on the Y. Pause the video and write the Y. All right, so your answer would be that the graph looks like it goes up 4 times the amount in this one because it's only going up by intervals of 5. Now number 3 says which is more accurate. So which of these gives a more accurate picture of really how busy these airports are? Number one shows really how busy they are. But which one gives a better, or which one is easier to read and to figure out exactly what number they fall on? Well, in that case, you've got number 2. Number 2 is easier to read. I mean, I can see right away, this says 75, this is more like 76. I never would be able to figure that out right here, that that's at 76. It would just be way too hard for me to guess that. So this is in some ways more accurate because it's zoomed in if I'm trying to find out the exact numbers, but it's misleading in trying to compare them to each other, unless I am really careful about seeing this break happening here. So which one's easier to read? 2. All right, page 2. Sometimes we use a break symbol to show that we skip some intervals in a graph axis. We do this to show data differences more clearly. Which graph is clearer? Okay, so here we have some information, right? We've got projected U.S. college enrollment, and here's our actual data. And then we have 2 different graphs that have shown it. So we want to know which one shows the differences more clearly. Well, in this one, there's no break, so the data starts all the way up here, and it makes it really, really hard to see their differences. It looks like it hasn't really changed very much at all. And if I'm trying to show the differences, then I need to zoom it in. And so that's what this graph does. It zooms it in. It zooms this in so we can really see the difference of it going up, and we can see this range between the 17 million and the 18 million, or 18, really like 18.3 million. Oh, 18.2 million. I can look at my data set. But why this is okay is because of this symbol right here. This shows us that there was a break in the data, that from 0 we skipped all the way up to 16 million. And as long as we put this little symbol there, it's okay to do that. It's okay to skip all that data so we can just focus in and use intervals that are actually going to be able to show our data more clearly. Okay, so example B, it says to use the graph at the right. In which year does it appear that the winning fish weighed twice as much as the 2001 winning fish? So down here we got 2001. So in which year does it appear that it was twice that much? It looks like 2002 is when it appears to be that much. Now, was it actually twice the amount? No, this is a little more than 14, and this is 10. So 14 is not twice the amount of 10. Do you think that the graph represents the data fairly? And explain. I'm going to have you do this one on your own. I'm really interested to see what you come up with. Okay, because you could make an argument possibly in both directions. So I want to hear whether or not you think that this graph is showing this data fairly, and why or why not. Okay, write that on your paper or in your notebook and bring it with you tomorrow. Go ahead and get to work.